Welcome back. In this session, we will introduce the concept of circular economy. At the end of this session, you should understand the concept of circular economy, know the two types of product cycles, and understand why solid waste management is key to achieve circular economy. Since the Industrial Revolution, our economies have followed a linear growth in the use of natural resources, basically consisting of take, make, use, discard. This has been based on the false premise that resources are infinitely available and accessible at a reasonable cost, both in terms of money and environmental impact. However, such a model simply cannot be sustained by the Earth system. On the one hand, material sources are limited, and on the other hand, there are limits to the resilience of terrestrial ecosystems in the face of habitat degradation and pollution by various hazardous chemicals. But, if we look at nature, natural ecosystems, and how nature uses the natural resources around, we see that nature works in a circular pattern. Starting with plants as producers, including many levels of consumers, and when they die, decomposers work to convert them back into soil nutrients, which in turn serve as food for the producers. Circular economy envisages a similar system, where after the make and use steps, the materials are recovered and transferred to a new production and use cycle. In order for the materials to be recovered and returned to the next production cycle, they must be clearly defined in a circular economy. The idea behind a circular economy applied in the field of waste management is to decouple the production of waste and the use of resources from economic growth, improve resource efficiency, prevent the use of raw materials. The materials can be defined either as biological materials or as technical materials. Biological materials are used to make so-called consumer products, which are consumed in use, such as soap or shampoo, or wear out in use, such as clothes or shoes. They are designed to be safe for human health and the environment, and can safely return to the natural life cycle as they are. Here we have an example of biological material, food. Technical materials are used to make service products, such as computers, telephones, washing machines, cars. As they are non-renewable and often dangerous for human health and the environment, they are kept in the industrial technical cycle, where they will be used to make new products, again and again. Biological materials often allow a cascade use, as is the case with textiles, for example, where quality deteriorates from one use to another, but at the same time during the process. For textiles, for example, there is first of all a possible reuse of the yarn, which will allow the production of clothes. Then these same clothes arrived at the end of line, the textile can be used to make carpets, for example, then finally as insulation materials. At the end of these cycles of use, the material can be completely returned to the biological cycle without danger to human health or the environment. They can be treated, for example, by composting or anaerobic digestion, to recover resources such as organic matter, nutrients, and energy. For technical materials, they can enter again the consumption chain after undergoing a stage of maintenance and repair, reuse, refurbish or remanufacture, and recycling. We usually distinguish recycling into three categories according to the quality of the final product, in comparison with the initial product. Recycling, same quality before and after recycling. Upcycling, materials gain quality with each recycling cycle. Downcycling, materials lose quality with each recycling cycle. In order to allow service products to reintegrate the consumption cycle, the design of the manufactured product is important. If the product is not designed to be disassembled, it is difficult to do so. As is the case with Apple products, for example, which are difficult to disassemble, and generally people who own an Apple product must go through an Apple store to be able to repair it. Since the goal of moving to a circular economy also takes into account improving resource efficiency, to achieve sustainable recycling, it is also important to see if it is possible to close the water and energy cycles so that the environmental impact of recycling is not multiplied tenfold. To achieve a fully circular economy, a lot of innovation will be needed in a variety of disciplines and in a variety of fields. For example, in the design of the object itself, the following elements must be considered. How easy is it to repair, renovate, disassemble, or remanufacture the product? Another important element is recycling, which requires good solid waste management strategy planning, as well as good coordination and collaboration among key stakeholders. This is it for this introduction on circular economy. Let's summarize what we heard about. We saw the difference between the linear economy model and the circular economy model, inspired by nature. We saw briefly the two types of product cycles that exist: biological materials for consumption products, technical materials for service products, which recycling process can usually be defined in three categories depending on the quality of the final product compared to the initial product: recycling, downcycling, upcycling. We then briefly mentioned key steps to achieve circular economy, being mainly design innovation, which could consider how easy is it to repair, renovate, disassemble, and remanufacture the product; and recycling, which is linked to good solid waste management strategy planning and requires good stakeholders coordination and collaboration. Thank you for listening. See you soon.